Problem number 2130, maximum twin sum of linked list. In a linked list of size n, where n is even, the ith node, the zero indexes of the linked list is known as the twin of the n minus 1 minus ith node. If if I is larger or equal to 0 and smaller than n divided by 2 minus 1. For example, if n equals 4, then node 0 is the twin of node 3, and node 1 is the twin of node 2. Node 0 is the twin of node 3. Okay. These are the only nodes with twins for n equals 4. The twin sum is defined as the sum of a node and its twin. Given the head of a linked list with even length, return the maximum twin sum of the linked list. Okay, so like we will have 6 and 6. Okay, so the maximum is 6. And for this, we will have 7 and 4. Okay, so the twin the twin of the ith node will be n minus 1 minus I. Okay. Okay, I think this is like a palindrome thing. Okay, there are these two nodes. So it's like yeah, we can have two pointers, and every time for each iteration, one of the pointer will walk 2 steps and the other will walk only 1 step. And when the pointer that walks 2 steps reach the end of the linked list, then the slower one will be at the head of the linked list that is twinned. Like, yeah, for example, for this first example, we have 5, 4, 2, 1, and we have 2 pointers, and for each iteration, one will walk 2 steps, 1, 2, and the other will walk 1 step. Okay, and then walk 2 steps, 1, 2 to 9. This will walk 1. Okay, so when the faster pointer reach the end, then the slower pointer will be pointing to the start of the twinned linked list. Then we can reverse this linked list, and then we can sum up from the head, from both of the head. Yeah, like we can reverse, so we will have 4, and then 4 will be pointing to, I think maybe, yeah, like this. then we can add 5 with 1 and 4 with 2. And we can have the maximum sum. Okay, so first we will have 2 pointers, slow and fast. Yeah, and we'll have time complexity equals ON, and space will be O1. And while fast has it's not null, or it's next not null, then we will have our iteration. We will keep moving to the next node. So for slow, we will move only 1 step, and for fast, we will have 2 steps. And then, yeah, we will be here, like, we will start reversing. So we will have, we'll have previous node, we'll have none, default to none, and the current node will be slow. So let's start. If current has value, then we will still reversing. So that's first store the current next to a variable, because we are going to assign current next to proof, and we need this variable to later on move on to the next node. So yeah, we'll have current next equals to proof, and proof will first move to current for moving to the next step, next node, and current will assign, we'll have next. Yeah. So after that, we'll have proof. After reversing, we'll have proof pointing to the head of the reverse node, a reverse linked list, and current will be pointing to the next node of this. So current will be none, since we'll have a while loop. Okay, so we'll have 2 heads now, and we will start counting our maximum. And for maximum, let's see what is the range of the sum. Okay, it's all positive, so we'll have 0. Then we'll start we'll have head 0 equals head, and head 1 equals proof. So yeah, let's randomly pick one list, since it will be the same length. And okay, then let's move our pointer once for each iteration. So head 0, head move to the next, and head 1 will move to the next. Yeah, I haven't done the calculation. Yeah, we'll have max sum equals max. The current value. Return max sum. Okay, I think okay, at least 2.2 notes. So we will first have like 1 to 2. So we'll first have 2 pointers here, and for this we will run for fast. It has value, so we will run into this while loop and move 2 steps for fast to the empty node, and then we'll have still pointer moving to 2. Okay, we'll start reversing. So current now is slow, current is pointing to here. Let's have current. So while current, yes, we'll run into this for loop. Next will be none. Current next will be proof it's none. So yeah, we're pointing to we're pointing to none, and proof will be proof will be here. Go to C, and then it will have this will have BC. Okay, so yeah, we'll have this pointing to none. Yeah, so proof is now 2, and we'll have head 1 is 2. Okay. Let's have H1 and H0. So we will start while H1, yes, H1 still has value. Yeah, we cannot use H0 since the connection is still here, so we have to use H1. Then the one with previous variable. Yeah, so next sum will be 0 with 2 plus 1, 3. So it will be 3, and then we'll move on to the next node. H0 will move into here, and H1 is here. Then H1 will not run again, so we'll return 3. Okay, seems great. Let's see.